Hello, welcome to Bigyanology. In this session of Bigyanology, we will talk about a demonstration experiment that is given in the NCERT physics book part 2 for class 12. It is in chapter 10, wave optics, and this is for a very important concept, interference and diffraction, that is described in this chapter. Young's double slit experiment is a famous experiment done to show the wave nature of light, in which from a source of light the light passes through two slits and then it falls on the board, falls on a screen, and then by geometrical optics one would just expect two bright lines corresponding to the two slits, and then in reality actually what one sees is a series of vertical bright and dark fringes, and this can be explained with the wave nature of light and interference of two waves. This experiment is very important for basic understanding of quantum mechanics also. Now, a related phenomenon is diffraction, and diffraction and interference, these phenomena happen when light passes through a slit or a hole whose thickness is very small, comparable to the wavelength of light. And the demonstration experiment for diffraction is with two blades. One can go to the chapter and read up about it, but today we will do an actual demonstration. So here is our arrangement: a very simple cardboard and a square hole cut out in the center. We can see from the back side, this is where a square rectangular hole was cut out, and then on the front side we have fixed two blades just touching each other, leaving a small narrow slit between the two, and this produces a single slit, and we can see a single slit diffraction pattern with this very simple setup. However, when we try, actually it needs some practice doing with the blade. There is another variant of this experiment which is even simpler to achieve. This is a board, a square hole has been cut out, and in the middle of the hole there is actually, right here, there is a human hair running through the board. We will see that as we shine laser light on this board. We will need this board with a hair and a very simple pointer laser. Let me power on the laser, and as it crosses the hairline, maybe you can see a bright spot, and that is where the hair is. Now we will make the room dark and do the experiments. we just saw how easy it is to get a fringe pattern, interference fringe pattern with a single hair and a simple laser. Now, to make the arrangement stable, we fix the cardboard with the hair with a chemistry test tube holder, and the laser we simply fixed on a plane with a tape which can keep the light on and fix its position. There are many other possible arrangements with which you can make the laser beam and the plane of the hair stable. So now we have arranged so that the fringe pattern is stable on our board, and now we will do some measurements with it. We want to measure the width of the fringe. So this is the central spot. Then I am marking the dark bands, location of the dark bands on either side, so that we can measure the fringe width. So I have marked 3 on either side and the central one. So the width of the central peak I measured with a scale 3.6 centimeter, and the average width of the 2 side fringes, this one and this one, comes out to be 1.65 centimeters. This is okay. 1.65 is about half of 3.6. Exact half would have been 1.8. Now we have to measure other distances. So the distance I want to measure is the distance between the screen, that is our whiteboard, and the plane of the hair. So I do that with a simple measuring tape, and let's see, the distance is coming out to be 163 centimeters. So now we have all the distances needed for applying the formula for the fringe pattern that is in the book. Formula will be beta equals lambda capital D divided by small d. Now capital D we measured 163 centimeter. Beta is measured 1.65 centimeter. The measurement is not so accurate, so I will take 1.7 centimeter. And lambda, that is the wavelength for red laser light, we can look it up, and it is about 650 nanometers. So now we know lambda, we have measured capital D, we have measured beta. From this, inverting the formula, we will be able to measure the thickness of human hair. Let us see what it comes out to be. So small d is equal to lambda into capital D divided by beta. I plug in the values, 650 nanometers into 163 centimeters divided by our beta 1.7 centimeters, and if I do the calculations, it will come out to be about 62.3 micrometer, which is our measurement of the thickness of the hair which we use. There will be some error because this 1.65 centimeter measurement is not very accurate, and the 163 centimeter measurement is also not accurate, but this is about the width of the human hair. It is somewhere between 50 and 80 micrometers. Also, we could do the experiment slightly differently. We could measure the thickness of the human hair with calipers, and then if we shine a laser, in let's say a green laser, then we can find out the wavelength of the laser from this experiment. So we demonstrated today how to do Young's double slit or diffraction experiment with simple setups like 2 blades on a cardboard or a piece of hair on a cardboard and a simple laser light. You can try this out at home. It is very simple. Just remember that one has to be careful about the blades, and also the laser light, pointing the laser light directly at the eyes can be dangerous. If you have comments, please put comments in the comment box. If you like the video, and share it and subscribe the Bigyanology channel. Thank you. Have a nice day.